Hello, everybody. My name is Dr. Amir Abbas, and with us today we have Dr. Khalid Nawab, who is an assistant professor in the Penn State University and is an hospitalist. And today we are going to talk about different aspects of health data science. And this is going to be a kind of a discussion or an informal, like we'll let the discussion lead us. And first of all, Khalid, thanks a lot for giving us time at this
Of
late hour.
course, of course, my pleasure. Thanks for having me.
Yeah. So before we go forward, would you like to tell us about yourself, especially your clinical background and your
Yes,
relationship with the health data science?
yes, of course. So, as you can see, my name is Khalid. I graduated from Khyber Medical College in Peshawar, Pakistan, and then I moved to the U.S. for my internal medicine residency. I did a 3 years residency in Mount Sinai Bronx program in New York. After that, I graduated from the residency in 2016, and I have been working as a hospitalist in around Harrisburg, Pennsylvania. A hospitalist basically means I do inpatient medicine. I don't have an office. Only see patients that get admitted to the hospital. So I've been doing this since 2016, July 2016. Also teach medical students from Penn State, since I have the title of clinical assistant professor. And then over the last 2 years, over time, I have I started having interest in data science over the last 2 years, I would say, and then took me, I would say, almost a year to reach the conclusion that this is what I want to pursue and I want to be involved. So then I decided to go for a master's. I'm currently enrolled in a master's in data science with Harvard Extension School. So yeah, that's about me. Yeah.
So, Khalid, like, how does that combine? Like, you being a medical doctor, and then you being a clinician, and then being the data science. So, how does that combination work, right?
So, very good question. Traditionally, when we think of medicine and computer science, we think of them as like two completely separate, fields, and which is evident, like not just in Pakistan, even here in the U.S., because a lot of the senior doctors struggle working on computers and they're used to paper notes and all. But over the last few decades, everything is computerized. You simply cannot live without the computers. And then so there's no way that you can survive in the modern world, as a doctor, without using a computer. Um, and so, as far as I'm concerned, I've always had interest with technology and computers in general. But then, when I moved to the U.S. and I started working on the EMRs, or the medical record softwares, and I realized that they're actually there's like a universe of data. There's so much data generated every day, and we rely so much on the EMR and on the computers. But most of these EMRs are not very user friendly. It's almost as if the EMRs are lagging in interface and technology compared to how softwares in the rest of the fields are. And one of the reasons why I believe is that traditionally it wasn't doctors who started the EMR. Like, it's the doctors or nurses or healthcare providers talking to programmers, and those programmers building those software. So even though they did what they could, but because they're not the ones actually using the software, it wasn't like the design is not that efficient. So I think slowly with time, we are realizing that we have to train doctors and healthcare workers to build these softwares and these systems, because the person who will be using it the most will be the person who would know what they need and what they want. So there are a bunch of doctors like myself, who work with closely with computers or computer science related fields or data science, and the number is increasing. And I think that we are kind of like the missing link between computer science and healthcare. Um, and even though there are very like not that many of us right now, but the number is definitely increasing. The demand is increasing, and with time, it's only going to increase. So I think it was just a matter of time until that we started seeing healthcare providers starting to move towards more computer science related fields. And same applies to me. Like I said, I've always been interested in technologies, and you know, I had this break when I signed the contract with the residency, and the residency started. I had a break of about like 6 months, and that's when I really looked into it, and I like read some tutorials, and I learned Java, which was the first programming language that I learned. And then during residency, I forgot. But then during like, basically, I didn't have time to work on it. But I was using the EMRs, and I moved to the US, and I realized that um, the beauty of here in the US is that you can do whatever you want, you know. So once I was done with my residency, I revisited the idea of me self-learning programming, and then I started reading more and more about data science, artificial intelligence, things like that. And did a few personal projects. I published a paper, and eventually I was like, you know what, this is what I want to do. I'm not alone. There are a bunch of doctors doing it, and I want to be one of them. Yeah. Sorry, that was
Yeah,
a
so,
story.
yeah. So you talked about a lot of things, and let's go into the details of them. First of all,
Mhm,
you talked about EMR, and I agree
mhm,
with you. And I think because I'm not a practicing clinician, but for academic reasons, if I've seen some of the EMRs, one thing which a question which I asked my professor here as well at Carnegie Mellon University is that why are they not I mean, like they're not very attractive, right? Do you agree with that
mhm.
aspect of it? Like I
Yeah.
mean, like the functionality of it and the other details of it, that is another thing because you people have to do it. But just like for the sake of demonstration,
Yeah.
somebody was demonstrating it to me, and they were like so ugly for
Yeah.
me. So what is your take on that aspect?
Yeah, no, yeah, that's the first thing you would notice about any EMR. They're ugly. You know, your usual Windows, your basic Windows operating system, it looks a lot more prettier than any EMR. But you have to think of it. I think the reason is that they wanted to make it as simple as possible. And also remember that hospitals, there will be like 500 computers logged into the EMR server at the same time in one hospital, you know. So you have like tons of computers. You have nurses walking around with computer stations, you know. We call them cows, like computer on wheels, um, things like that, you know. So the software has to be light, you know. Um, it has to load efficiently. There should be no lag. And if you add all the colors and the graphics, you know, they can be hardware intensive, or even like data intensive. So it may take longer to load and stuff. So I think one of the reasons why they appear so simple, is just because they want to make it as light in terms of data, as possible, so that everything is a lot more efficient and quick. Um, another reason why they're so they look so clunky and ugly is that there's just so much information, and they want to sort of put as much information as possible on one screen without you having to click through. So that may be another reason. But yeah, but I agree. I completely agree. They all look very ugly, and like just by looking at the screen, you're like, oh my god, I'm bored already. You know? Yeah.
So I might be talking about like this is the first thing which I want to base our discussion on, and I may be talking about things which are beyond my field. But I mean, like talked about load, you talked about simplicity and things like that. Take the example of a simple email, any email, like say Gmail, right? Like
Hmm.
starting from a very educated person to very little, I mean, a person having little education. I mean, you have platforms that everybody uses. Take like Facebook, right? I mean,
Hmm.
Facebook is, I would not say it's a very completely simple platform. There are so
Hmm.
many options, but all of us use it. And I think all of us know, I mean, I know people like they will manage their settings and things like that.
Yeah.
But I think, and when I asked the same question to my professor, and she is one of the authority on this field, and her answer was that not very a good design. Like, okay, there are people who design this stuff in the healthcare space. They just focus on the things which you mentioned and which are important as well. But at the same time, okay, like you have a boring job and you have to enter the data into that system as well. So you would want, you will want something like to be at least user friendly.
Yeah.
I'm assuming that
Yeah.
it is user friendly with something beautiful as well. So what is
Yeah.
your take on that aspect of things?
I agree. I think should look pretty. Everything should look pretty, you know. But
Yeah.
of course, functionality is very important. So there should be a balance between the two. It should look pretty, but more. See, we're in healthcare field. The focus is providing care to sick people. You know, so I think they have focused a lot more on adding functionality to the EMR, and they have worked on making it as efficient as possible, and that may have taken focus away from it looking, pretty and with all the bells and whistles. But it depends. Some of the EMRs are definitely like with we use Epic. Um, and Epic, I think it has come a long way over the last 4 years that I've been doing this job, and we've had like one or two upgrades. So you see with every upgrade that they are optimizing things, and the software feels a lot more intelligent compared to what it was 4 years ago. So I think it's getting there, but yeah, I don't know why they didn't focus on um, it being looking more friendly, but I think the main reason was that the focus was more on functionality rather than the user interface.
Right. So you talked about a bit about, first of all, a number of things. As I said, you talked about Java. So can you educate me, a person like me who doesn't know anything about Java? Okay, what
Okay.
is, like just in the layman terms, like,
Yeah.
okay, for a doctor who doesn't know anything, what can Java? If I learn Java, what can Java do for me?
Yeah, sure. So I mean, I learned Java in the context of Android apps development. However, so well, if I really have to go in layman terms, so it's a programming language, and a programming language is sort of the way I would define it is that it's a collection of commands for the computer. You're telling the computer how to do something. So it's that language between you and the computer, and the programming language is how you make the computer understand what you want it to do. So Java is probably one of the most popular, if not the most popular language, and it comes in various forms. You have the JavaScript, you have the script running on web apps and online, and then you have Java for Android programming. And I've only worked with the one, in the context of Android apps development. But I believe that the core, syntax is the same. So the way you write Java in its different forms is the core is likely the same, with maybe little changes here and there. So yeah, it's a programming language. What can it do for you? It can do wonders. Um, my my understanding is that it's very popular for web apps or web page programming, and a lot of JavaScript runs on a lot of the websites, and JavaScript will generate dynamic web pages for you. So if you look at the source of the page that you are seeing, you may see simple HTML, um, but that HTML code is sort of generated by the JavaScript running on the server side or in the background. So Java can do that for you. Android programming is based on Java, so all your Android apps, a lot of them. I mean, now we have We have other platforms or cross-platform, languages or applications, but native Android apps, at least initially. I moved away from Android, so I don't know where the world is now, but back then at least all the native apps were based on Java. So yeah, it's one of the strongest programming languages, I believe, and it can do a lot for you. I would like to add a disclaimer. I don't have a computer science background, and I'm mostly self-taught, so I may say things that a lot of the computer science people may not agree with. But I would like to point that out, that it's purely based on my limited experience and my understanding and interpretation, and not necessarily on any academic training. This master's in data science is the first formal education in computer science that I'll be getting. Yeah.
So, would you call this master in health data science
Sure.
master in some aspect of the computer science, or this is statistics, or this is like,
Sure.
oh, how would you classify that? Okay, I go
Yeah.
to Pakistan and then
Yeah.
I go to university. How do I tell them what I've done?
Sure.
Should I go to computer school, or should I go to medical
Yeah.
school? Like, where should I go?
Yeah. So what's interesting about my program is that it's not specific to healthcare. It's just data science. So wherever you have data, you can apply data science. It's not health. It's not like healthcare informatics or healthcare data science. So you may ask, what is data science? So data science is when you have data, how do you make sense of that data? How do you extract meaningful information from that data? And then in the broader picture, in the corporate world, how do you translate that into a business model, or how do you translate that into a process that helps your daily life? Makes it more efficient, or makes you more money, or in terms of healthcare, gives you better outcome with patients. So basically, data science is how do you make sense of data, and how do you apply that sense in your daily processes to make them better. So my program is not healthcare specific. It has a lot of, the curriculum is very interesting. It has a lot of courses, and as you may know, data science is very Python and R heavy. I tend to choose courses that are based on Python because that's what I'm more comfortable with. Um, you mentioned if it's like, what is it? Is it computer science? Is it statistics? What is it? It's a combination of everything. I would say it's a subfield of computer science. However, if you look at any of the curriculum of MBA or anything with management now, and anything involves data, you will have a few courses on data science included there, because in modern world, there's data everywhere generated on daily basis, and to understand it, you need some data, science skills. So there are various domains of data science. There's data collection, which would be something like web scraping, or in terms of healthcare, collecting data from like IoT, Internet of Things, so all the different devices, or the charting done by healthcare providers. So that's data collection. There's data plotting or charting. So how do you represent the data in all different, graphs, charts, things like that. There is machine learning, artificial intelligence, deep learning, all those side where you give the data to the computer, and you let the computer identify trends, and then the computer, if you give it new data, it will try to predict the outcome, or try to interpret the data in the context of the previous data that you have provided to your model or your computer. There's a big field right now is computer vision or image processing, which we're seeing everywhere. Your iPhone identifies pictures that you upload, your Facebook, facial recognition, self-driving cars, security systems, and then in healthcare, all those models that interpret CAT scans or chest X-rays or other X-rays, all the imaging studies. So it's a very, I mean, there are so many domains of data science, so many applications, and I can go on and on. But my program specifically, I why I like it is that it's very broad. It doesn't limit you to a specific profession or domain. So I could apply it to healthcare. I could apply it to a business model. I could go and tell people, I can teach computer science people, I would hope, so it's not pertaining to a specific domain, and it's just a broad program which can be applied anywhere there where you have data.
Right. So I have this understanding that you need some mathematics skill as well. If I have to become a data scientist, so what kind of mathematical skills do I need to become
Yeah,
a data
yeah, yeah.
scientist?
Uh, Good question. Difficult to answer for me because like I said, I'm a doctor basically, but definitely you need a lot of skills. Skills, as in terms of, nobody's going to hand you over a paper and pencil and ask you to solve an equation, but you need to understand a few things, and mostly in terms of machine learning, linear algebra, and your arrays, things like that. What's interesting that if you look at the history of data science and specifically artificial intelligence, it did not start as a field of mathematics.
Hmm.
um, Historically, they were not related, and people always thought of it as something separate than mathematics. But with time, we started including more and more of the statistics and mathematics, and now we actually say that everything machines understand numbers better, so we need to find a way to represent non-numeric data as numbers, and that's when we use arrays and vectors and all that. So mostly linear algebra is what I would say that you need to understand the basic concepts. Um, there are a lot of equations involved from algebra and your mathematics. If you can remember them, great. Practical applications, definitely helps to understand the basic concepts, but you don't need to master them. Luckily, um, we're in a time period we don't have to write everything from scratch. We just need to learn how to use certain libraries. Definitely, if you have the skill level to write your own library, great. But you just need to understand the basic concepts of linear algebra, and then you have to learn how to use the different libraries that Python or R would provide you. Yeah, but if you look at the theory of it and the concept behind how those models work, you definitely need to understand a lot of mathematics, and they're based on statistical and mathematical models.
Right. So simple question. What is, you're talking a lot of these languages, and I'll say, and you mentioned Python many times. So is that an animal, or like what is that, right?
Well, it depends in what context you talk about it. Python is an animal,
Yeah.
and then many other
And
contexts.
then like the terms anaconda,
Yeah,
spider, python, and like,
sure.
and there's, you must be aware of pig, right? So like, why are you, first of all, why use the names of the animals? Is there any
Yeah, I honestly don't know why. I don't know where it came from.
yeah.
It would be interesting to look it up. But yeah, Python is a programming language. It's very intuitive, so it's very easy to learn. And I feel like unlike Java, where I feel like Python gives you a little bit of liberty. You can, if you miss something, your code may still run. Um, Java, I found, was very complicated for me, at least. Um, it wasn't that easy to learn, and a little bit of indentation is a big issue in programming. Everybody knows that. But I feel that Python is a little more forgiving and easy to learn as compared to Java. Which is why you have all these, self-taught Python programmers, I guess. But yeah, and then you mentioned things like Spider, Anaconda. So every programming language comes with something we call an IDE. So it's an integrated development environment, I guess that's what it stands for. So So the programming language comes with a certain set of other supporting files and libraries, um, and how you write the script and what you write it in. So that's basically an IDE. So you have all these different IDEs that that you can use to code for any language. So the popular ones, at least the ones that I use, is Jupyter Notebook is what I use, and it comes as a part of Anaconda, I believe. But yeah, so that's what I use. I think the reason I like to use it is that if I'm experimenting with something, or because I'm mostly learning while doing it, I can just run my code line by line as I type it, and I can go back and change it right then and there. The other one that I've used a lot through my course, my program, they really encouraged us to use PyCharm. Um, PyCharm is great. It if you write a code, it will sort of execute it in the background, and if there are any errors, it will show you like most good IDEs would. If you mention a library that is not installed, it will give you a warning and give you the option to install it, but you cannot run code line by line just like with the ease that you can do with Jupyter Notebook. Yeah, so you have all these different IDEs or software packages that you use to run these programming languages. And there's spiders there. I have not used it. Anaconda is one big package, which includes, I believe, the Jupyter Notebook as well. And Python is the programming language. Yeah.
So roughly, like you said, IDE. Can you talk like what do you mean by IDE?
So, like I said, it's the development environment, right? So basically, if you tell the computer, let's say you're doing you're writing code to do some mathematical operations. So someone has already written a lot of that code for you. You just need to know how to use that. So somebody who has already written a lot of code for you. So basically, you can say they have created a library. So that's another file set of code which does a lot of the heavy lifting for you. You just need to learn how to incorporate it in your program, right? So so for example, I will need those files to begin with, and then I will need a system where my code can interact with the computer and tell it that that's the library I want to use, make it available or install it. And then you need to write the code in something, just like when you type a document, you would type in Microsoft Word. So if you're typing the Python code, you have to type it somewhere, right? So the IDE is what provides you all that capabilities. It's a link between you and the computer. It will have all the necessary code to interpret what you write. First of all, it will have the interface for you to use where you write the code, and then it will have all the necessary systems required to understand, for the computer to understand your code and run it. So it sort of creates this whole environment for you in which you can talk to the computer, and that's what I would call that. That's how I would define an IDE.
Okay, so you talked about Python and then like what are you talking about R and other languages? So what is the difference between R and Python?
So I have not worked with R that much. So I really can't speak for it. I had one course on R, basic R, and I did not like it. So like I said, I've been steering more towards courses that rely on Python, not on R. But R is my understanding is that it's another sort of language like Python. Um, so Python and R, like Python has both of them, but especially Python has become a lot more than just a scripting language. But previously, like if you want the computer to do certain operations with the data, so you write a code, you don't have to build like a full software. You just write a set of code, kind of like script, giving computer a set of instruction. And R is also a language just like Python. It's very my understanding is that for data processing, it's very efficient. It has all the right tools that you would need, just like Python. And it may be for scientific data, it may actually be better, R may be better than Python. Or if you have like large amount of data, um, with numeric data and things like that. So R may be better than Python in some cases, but my experience with R is very limited. So I don't know.
Right. So R is like more geared towards statistics, and
Yeah.
Python is more towards like computer scientists better like Python, statisticians better
Yeah.
like R,
Yeah.
because R is a language, if you know, that has been developed by a statistician actually. Like
Mhm.
Python is basically a computing language, and
Mhm.
I mean, it's just like of a discipline thing. And when you do data analysis, I personally find R better than Python because of my background, purely because being an epidemiologist and biostatistician.
Yeah.
There are better data visualization and better libraries. So in that context, okay, moving forward, you said machine learning, and for the first
Mhm.
time when I heard of this topic, like at this time, though I've academically studied it, so I kind of know where it is. But just like for the first time, when I heard of it, like I thought that okay, there will be we'll be talking about, we'll be thinking of something related to machines and like how different machines work. So what was your, like? We will go into the discussion
Yeah.
of what machine learning is, but what was your first impression when you heard of this term machine learning?
Yeah. Yeah. Very interesting question. And we have all heard of AI, artificial intelligence, which is what this general, term that we hear. And thanks to science fiction movies and shows and all that, right? And we keep hearing AI, AI. So for me, hearing the term machine learning was very, very interesting. And I think the first time I read about it was, um, uh, well, actually, yeah, the first time I read about it was on this website, Quora. I don't know if you guys know Quora, and it's a website where people ask questions, and then other people answer, and they're not just like your usual Googling answers. Like a lot of experts would answer very detailed answers to some questions. So I heard that, I read the term there, machine learning. It was very interesting. I mean, I did not imagine like machines with a lot of mechanical parts, like you did, but it was interesting. I think the term itself, it tells you what it means. So how does a computer learn, or how does a machine learn? But yeah, it was a new term for me too. I had always heard the term AI, and then machine learning, and then deep learning, things like that.
Yeah.
Yeah, yeah.
So coming to the question, what is machine learning?
Sure. So I mean, first of all, you need to understand what is learning. You know, and it's learning is basically how you do something. I mean, to us humans, it comes instinctively, and nobody like sort of, it's funny when I put it this way, but nobody teaches us how to learn. That's just how our brain is modeled, right? So machine learning is basically how do you um, like without giving the computer instructions, you just give it the sort of, you give it the path, or you give it the outcome and the data, and then you let the machine figure out how it's done, um, or how do you train a machine, or how do you make a machine do something without giving a specific set of instructions, um, so basically, learning would be if the machine can do a future task without you giving it specific instructions on how to do it, and it learns it by looking at how you have done the previous tasks. So it sort of imitates how we do it. Kids watch us doing something, and they try to imitate, and then that's how they learn. So machine learning is how does a machine does a task that was previously done. So it tries to imitate you in that task and tries to do it that task. Try to do that task. I wish I had a better explanation, but
Yeah, so that is an interesting explanation. I think that clarifies my concept of how kids get trained, right?
yeah,
So I think, I never thought of it in that way. But what do kids do? They're like inquisitive
yeah,
creatures. They are looking for data. Like in simple terms, what they're
yeah,
doing. Okay, what is this?
yeah.
What is this? Now they find out a color. Okay, this is
Mhm,
apple and this is red. So this is
mhm,
red apple. Next
yeah,
time, like they keep on improving. Like so, that is how a machine learning model works. I think like okay, it takes the data, it
yeah,
does something, and then it is getting tested on the prediction, and like
mhm,
okay, then you get to know, the machine gets to know, okay, like it has done
yeah,
right or not right, and
yeah,
then ultimately, so it's a very
yeah,
interesting analogy. Like
yeah,
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 I agree with you.
yeah,
So and then what is deep learning and other things, like we keep on
yeah.
complicating the terminologies.
Yeah, yeah. So, uh, which is deep learning again, a lot more harder to explain for me at least, um, but kind of like the same thing. But deep learning is where I don't know how to describe it in like really, really layman terms. But deep learning comes from sort of um, well, the idea is based on neurons, the connections between neurons. So you have all these nodes of information that are connected to each other, and information is passed around. Um, and the goal is that how does the computer reaches the right outcome, the right result. Um, I think I'm not sure where the term deep learning comes from, but in really, really layman terms, where you give the computer the data and the outcome, and you let the computer repeat the process and try to adjust, its numbers so that the data, like basically if you tell it 2 plus 2 is equal to 4, you let the machine figure out how we reach this number 4. So it
Hmm.
will do internal calculation and adjust the different numbers to give you this number 4. So next time if you give it 3 plus 3, it will try to apply the same, the trends that it has noticed, that how we reach from 2 plus 2 to 4. It will try to apply that to the future data and try to reach the answer, the right answer. So we don't know how the machine decides how it went from the input data to the output data. We don't know the internals of it. I mean, we let the machine decide that, and we may not know it completely, which is probably why it's called deep learning, which is one of the biggest challenge with AI and some of the machine learning or deep learning tasks, is that it's not explainable, which makes it very difficult for people to understand. And it's not some magic. It's not like there's some mysterious thing happening. It's all mathematics. But basically, deep learning is where it tries to mimic the neural network like we have in our brain, passes information from node to node, and tries to deduce it to the result. And it basically tries to identify trends that we may not see, and then on future data it tries to reach the right answer. I don't know. I wish I had a better way to explain it, but
Yeah, that's okay. I mean, we got an idea. So let's move gears into the types of data. And like we discussed, that there are different types of these terms, which is machine learning, deep learning, data mining, which leads to artificially intelligent solutions. But uh, like, okay, you cannot do anything if you do not have the data, right? Like that is the main thing
yeah, yeah.
which we have. Now, when we talk about data, how do you explain the structured data versus unstructured data?
Sure. So you're asking me what is structured data and what is unstructured data.
Yeah.
Um, okay. How can I? Okay. So for example, um, so so let's say, like, I'll give you an example of my project. So we got 5,000 patient feedback comments. That's unstructured data. It's not classified. It's not. There isn't a, here are 5,000 comments. This is your
Hmm.
data. This is unstructured data.
Hmm. Hmm.
Um, But if the data is arranged, it's already classified. This is positive. This is negative. You
Or
know,
that is in the spreadsheet, right? Like in the form of an
yeah,
Excel sheet.
yeah,
Yeah.
exactly. It's not a random pile of papers, but it's already tabulated, classified, arranged. So there's a structure to it, that's structured data. But a random chunk of data, a random chunk of, piles of paper, or the 5,000 comments that I got that were not classified and not cleaned, and nobody had gone over that, that's unstructured data. Um, mhm. Yeah.
So, I mean, the structured data analytics have been going on for quite a time. Like traditional example is SPSS, data, SAS, and things like that. That have been in the market for like decades. Now you are saying that okay, now we have the ability to analyze like patient history,
Mhm.
imaging, things
Mhm.
like that, and like put them into analyze in them in the same way as structured data. So how does that work? Like for example, if I have a list of patients, and let's assume I have a patient of a particular condition, how would I analyze their histories and convert them into structured form?
Sure. So this is where machine learning comes in very handy. I feel, So what you're doing is that you're training a computer to extract meaningful data or structured data from unstructured data. So a lot of the healthcare data is unstructured. It's me talking to, like me typing in the patient. Uh, Say 55 years old, male patient came in with this. So I'm just saying, and I'm just typing all this. So a human, a doctor that's reading it will understand it, but a computer will not. How are you asking me, like, how do we change that into structured data? Yeah, so we sort of, you train systems, you train the computer on identifying items in the data. This word represents a symptom. This word represents a diagnosis. And if you combine this symptom with that symptom and that lab value, so this is likely leads to this diagnosis. So you train the computer to understand that, and then you let the computer analyze the unstructured data and extract the meaningful information and like sort of give you the structured data. Um,
Right. So, in the same way, like we can analyze the history information, we can analyze the
mhm.
imaging,
Yes.
and maybe ultrasound, ECG, and everything, right?
Yes, yes. I mean, yeah, the basic principle is the same. You train the model on the data you give it, and give it the data, you tell it the outcome, and then if you give it prospective data, it will try to get you the answer, based on that. It can apply in healthcare. You have a lot of that. You have so the basic, which is a very difficult task to do, is extracting data from patient notes. There's a lot of work going on that. But I remember reading a paper where they said that from the notes in psychiatric conditions, it works very, very well. I think it was conducted by Mount Sinai in New York. Um, and they said that for mental health, conditions, it works very well, but not for other stuff. I'm sure that has changed over time. This is
Mm,
like 4 years ago when I came across this paper.
mm,
Um, but yeah, imaging is, I guess, relatively easy because you're classifying pixels.
mm.
Easy to convert to numeric, the pixel values, and probably the conditions are sort of limited on imaging, whereas textual data, like your charts, there's so much that one person can say, and it varies from person to person. There will be a lot of similarities in chest X-rays of two people, so it's less data for the computer. But what I type and what you type, the language may be completely different. Our choice of words, the way we spell things, so many things. So special text is very unstructured data. It's very challenging, and there's a lot of that in healthcare.
Right. And adding to that, as you talked about mental health, so there is a separate field which has recently emerged, and it is, though it is still in the beginning, but it's called as computational psychiatry, actually, which uses all of these techniques and applies
Mhm.
in the mental health space, and I think none of the other discipline has a separate a
Hmm.
name for a combination of a clinical discipline
Hmm.
with the data science discipline.
Yeah,
So that
yeah,
is kind of an interesting
yeah.
area.
Very interesting.
And like I'm assuming thinking of getting in touch with some of those folks like who have worked in computational psychiatry and learn from them, like maybe write to some of the authors from different papers on computational psychiatry. So like we are near to the end of our discussion, and like a final few points is like, do you see like I've been seeing the words like AI for diagnosis, AI for prognosis, AI for identification of drugs. So do you think that okay, we will in the near future say goodbye to laboratories and
Yeah.
they already maybe yeah.
No, I honestly don't think so.
Okay.
I don't think we need to look at AI as our enemy and AI as replacing humans. I mean, I'm not saying that it will not replace some job. It definitely will, but I think the human element will always be there, and and it will be more of an assistant rather than like making all the decisions. Maybe I think we are far from that time where it will completely replace humans, but it has definitely increased the rate of progress in research because it's very interesting. Actually, they applied some models to old data from old researchers like 10 years ago, data from 10, 20 years ago, and the models were able to identify things that were missed by the original investigators. So it is happening, but I don't think it will replace humans. The human element will always be there. It will just be more of our assistants. But definitely we're seeing more and more of that. For example, a lot of people are worried that it might replace radiologists, but currently some hospitals are using or developing systems that will help the radiologist prioritize. So before the radiologists get to the 10 MRIs, AI will identify the ones with possible abnormal images, and it will tell you maybe you should look at this one first. So it's not replacing it, but it's actually helping the radiologist in prioritizing which images to look at first. So I don't think we're anywhere close to AI replacing us, but definitely assisting us in a lot of the research work.
Right. And additionally, I think one important application can potentially be taking these solutions, making these solutions, training models on them, and taking to resource limiting countries like Pakistan,
Yeah,
India, Bangladesh,
yeah.
and using them for a preventive purposes, and where you cannot take I mean, where you have limited resources,
Mhm.
you may reach to a point, you make an algorithm, you validate that algorithm with the help of studies and use those algorithms over
Yeah.
there in those resource limited things. So what do you think about those
Yeah, and
applications?
it's already happening. I think it's very useful. Google came up with a device, an ophthalmoscope, where you take pictures of the retina, and the system will identify people with possible diabetic retinopathy, I think, and then the ophthalmologist will see only those patients. So instead of having, say, five ophthalmologists screening 500 people, you have four nurses or four volunteers, train them how to take pictures of retina. Let the device classify the retinal images as whether they have retinopathy or not, and then only refer out of the 500, say 50 people were identified by the system, so only those are examined by the ophthalmologist. So they were doing it in India, and I think it was controversial, and then I don't know if it was the same device. Eventually, they found that it wasn't as accurate, but you see the potential application. If you build a system that works, definitely will help will help developing countries. And I think there is another system which triages patients based on their symptoms. It's used in Africa, where the nearest hospital is like a few hours away. So a nurse sits in the clinic and triages patients and decides who needs to be transferred to the city. So using AI, and it's easier to implement those in developing countries because they're desperate. They would rather have that than not have anything at all. In the US, it can be challenging because of all the liability and legal issues and things like that, ethical issues and all that. But developing countries definitely will use whatever help they can, and definitely a lot of potential there.
Right. So, final question: if I have to learn all these data science skills, these languages, or
Yeah.
and I don't have money, what should I do?
You honestly, you don't like even the latest trend in big tech is that they're moving away from college degrees. They look at your skill level and your portfolio rather than your degrees. So YouTube, you can find like thousands of videos, and that's how I learned Java, from YouTube. And Python, most of it learned from Udemy, which you could easily find a $11 course there. But you don't even have to do that. There are countless blogs, countless YouTube videos. I call myself a copy paste programmer. If I don't know what to do, I'll just find some code somewhere online. I understand it enough to make changes and then use that. So you can definitely be a self-taught data scientist. I have actually seen blogs who have lined out the whole curriculum for you, what you need to learn, and all for free. You don't need any degree. You don't need to spend any money. You can definitely do it on your own and work on a few projects, build a portfolio, and that, you may be able to get a job using that portfolio. Yeah.
What about courses in Coursera or edX or platforms like those?
Yeah, that's what I said. Like I used Udemy for some reason. The thing is that there's a course that I did, Introduction to AI, from Harvard Extension School, and the entire course is available online for free with the same material, same code, same videos. The only thing they want you to pay is if you want course credit for it, but it's available for free, the entire course, and it's an amazing course. So definitely edX, Udemy. You have so many options out there, and they're definitely helpful. You just have to stay persistent. Some of us need to have the pressure of deadlines and a professor wanting an assignment from us to be able to do it. But if it's something you want, you can set deadlines for yourself and try to do it on your own, and you can definitely do it.
What is the title of the course? Can you repeat that? What you said?
Simple intro to AI. Yeah.
Intro to AI. Okay,
Yeah.
so with that, I think this is quite late, and next time we will plan on a better time. I think this was organizing it this late was not a good idea. But
Yeah, yeah.
it
It
was
was
just on
fun.
the basis of mutual availability. So thanks a lot, Khalid, for
Of
giving
course.
us time this
Thank
late,
you.
and we will see you again
Yeah,
next time. Okay,
hopefully
take
soon.
care.
Take
Okay,
care. Bye bye.
bye, bye, bye.